Hi, and welcome to Math for All. In this lesson, we're going to be looking at very short looks of how to stretch our parabola. We can stretch it horizontally, we can move it horizontally, or we can also move it vertically. Let's take a look, let's have a glimpse at how a parabola can actually stretch. We have some examples in front of us. I like to have our whole numbers first. We can talk about fractional numbers just shortly after this. So if you have just a regular parabola, which is y equals x squared, it will appear as something like this. Something that's very wide, and as the number increases in front of it, usually if you're talking about a number that's in front of an x value for something like a linear equation, that number usually represents the slope. When we're talking about a parabola, it represents its stretch factor. So the higher the number is, the more it narrows. And so you can see that the parabola actually went from being wide open, y equals x squared, y equals 3x squared, to being very narrow when you have a stretch factor of 6 now, y equals 6x squared. Okay, when you weren't looking, I actually decided to change up the numbers a little bit. Now we have our fractions instead of whole numbers. So in this case, x squared is actually represented here in the middle. So going by what the original equation is, let's say it's y equals x squared. So using this as a reference point, we can see that whenever we introduce a fraction in front of an x squared, the stretch factor now makes the parabola wider. And so you can see that in this case, it widens more and more as the number is being decreased in front of x squared. In this case, we're going to be looking at a horizontal and a vertical shift of a parabola. So let's look at something like this. Whenever you see a square and the x is within a bracket, that's also a representation of a parabola. Let me show you why. If I was to write it out and actually expand it, I can write it in this form, because the square tells us that we're multiplying this by itself that number of times, so twice. So from previous lessons, you remember, in order to expand this and actually open up the brackets, we multiply the first number by both of these, and then the second number by these as well. Let's do it together. X times x gives us x squared. X times 3 is 3x. 3 times x is also 3x. And then 3 times 3 is 9. So we combine these like terms together, we get 6x, and everything else stays the same. And so essentially we're just going to graph this relationship. It's a lot easier to graph it when it's in this form, because what this shows you is that it shows you how much a parabola has moved. If you see a plus sign, the parabola has a horizontal shift towards the left. If it had a negative sign, the parabola would actually shift towards the right. Let me show you why. If you were to make this expression such that all of this would have to be equal to 0, x would have to have a value of -3. -3 plus 3 would give us 0. When you square 0, you also get a 0. So the parabola, which normally would be positioned here, which is y equals x squared type of a parabola, if it was written in this form, all you have to do is shift it over 1, 2, 3 units. There's no stretch factor. It still looks the same. It's just shifted over by 3 units towards the left. Okay, and finally what we're going to do is we'll actually add one more component to this. We've just talked about a horizontal shift, and now we'll add a vertical component to it. So anytime you see an expression like this and a lagging number behind it, let's say the number is 4, what that number tells us is that it tells us how much a parabola has moved up if it's positive, or down if it's negative. In this case, we'll just take the same parabola, and we have it here. We're going to move it 1, 2, 3, 4 units up. It keeps its stretch factor the same, and now it's positioned here. In fact, we can actually write in the position of its vertex at -3, comma, 4. And that would be a correct answer. Lastly, if I wanted to just summarize everything that we've done so far, we've talked about a stretch factor also. I can add a stretch factor to this parabola, and I could write in a number. If the number is a positive number and it's a whole number, the parabola would actually narrow. This is just a rough sketch. If it had a negative number, I'm not going to write it in, but if it did, it would look the same, but it would flip down. Now, if I made it into a fraction, and instead of making it a 2, but I made it into a half, so this was our original parabola, that half would make it even wider. And the parabola would actually look something like this. I know it's a lot of information, but keep in mind that we have our stretch factor, we have our horizontal shift. If it's positive, it moves towards the left. If it's negative, it moves towards the right. And the number that lags at the end, that whole number or a fractional number, whatever it may be, it still represents a vertical shift. In this case, the parabola moves 4 units up. If it was negative, it would move 4 units down.